Hey, I'm Antoine and I'm excited to present you our work done at Google, Vid2Seq, large-scale pre-training of a visual language model for dense video captioning. Our code is available on the project webpage. In a nutshell, Vid2Seq is a visual language model that predicts temporal boundaries and captions for all events in an untrimmed video by simply generating a single sequence of tokens. Such a unified model requires large-scale training data, which is not available in current annotated datasets. Hence, we pre-train Vid2Seq on millions of unlabeled narrative videos by reformulating transcribed speech sentences and their corresponding timestamps as pseudo-event captions and boundaries. After fine-tuning, the pre-trained Vid2Seq model achieves state-of-the-art results on various benchmarks of dense video captioning, video paragraph captioning, video clip captioning, and also generalizes well to few-shot settings. Now let's dive into the details, starting with a little bit of background. Most video captioning systems can only handle short, trimmed videos, but natural videos may contain numerous events. So we focus on the dense video captioning task, which requires temporally localizing and captioning all events in untrimmed minutes-long videos. Prior dense video captioning approaches contain various task-specific components, like event counters, which makes it hard to integrate them into powerful foundation models. In contrast, we take inspiration from unified frameworks like Pix2Seq and follow webworks that view spatial localization tasks, like object detection, as single sequence generation tasks. This is achieved by quantizing and tokenizing spatial coordinates. However, in dense video captioning, we deal with a temporal localization task. We also need to predict a caption for each event, and we have fewer manually annotated data for training. Hence, we designed Vid2Seq, a visual language model that views dense video captioning as a sequence-to-sequence problem. To achieve this, we quantize and tokenize time jointly with text. This enables Vid2Seq to seamlessly understand and generate sequences of text sentences interleaved with special time tokens that temporally ground these sentences in the video. In detail, input video frames and the transcribed speech sequence are encoded by a visual encoder and a text encoder, respectively. The text decoder cross-attends to these multimodal embeddings to auto-regressively generate the output dense event captioning sequence. The model weights are initialized with a clip visual backbone and a T5 language model. This unified Vid2Seq architecture requires large-scale training data, which is not available in current dense video captioning datasets. Hence, we propose to pre-train Vid2Seq on unlabeled narrative videos, which are readily available at scale. For instance, the YT temporal 1 billion dataset that we use contains 80 million narrative videos. For pre-training, we use the transcribed speech sentences and their corresponding timestamps as pseudo-dense video captioning supervision. Note that speech sentences considerably differ from dense event captions, for instance, in terms of semantic content or duration in the video. However, we will show in the experiments that this pre-training is highly beneficial for Vid2Seq's downstream performance. We pre-train Vid2Seq with a generative and a denoising objective. The generative objective teaches the decoder to predict the speech sequence given visual inputs only. The denoising objective encourages multimodal learning by requiring the model to predict masked token given a noisy speech sequence and visual inputs. After pre-training, Vid2Seq can be fine-tuned on various video captioning tasks with a simple language modeling objective. Notably, Vid2Seq achieves state-of-the-art results on 3 dense video captioning benchmarks: UCook2, VITT, and ActivityNet captions. Vid2Seq also improves over all prior video paragraph captioning methods, including those that use ground truth event proposals at inference time on both the UCook2 and ActivityNet captions datasets. Finally, Vid2Seq also generalizes well to the standard video clip captioning task, as it achieves state-of-the-art results on both the MSRVTT and MSVD datasets. We also find that the pre-trained Vid2Seq model generalizes well to few-shot settings when fine-tuned only using a small fraction of the downstream training dataset. In our paper, we further show that pre-training is crucial for the future performance. Our ablation studies demonstrate the benefit of pre-training on untrimmed narrative videos by exploiting transcribed speech timestamps via the time tokens. This is unlike prior video captioning pre-training frameworks, which make use of short, trimmed video speech segments. We also analyze the importance of each pre-training objective. We find that the model with visual inputs only benefits considerably from pre-training with the generative objective. Furthermore, the denoising objective significantly improves the performance of the model with both visual and speech inputs. Moreover, after pre-training, jointly predicting captions and timestamps improves the temporal localization performance compared to only predicting timestamps. This shows the importance of contextualizing the noisy timestamps of the transcribed speech sentences with their semantic content during pre-training. In addition, Vid2Seq benefits from larger language model sizes and scales positively with the size of the pre-training dataset. These scaling properties make Vid2Seq a promising framework to build future video language foundation models. Qualitative examples show that Vid2Seq predicts meaningful and event boundaries in captions. Furthermore, these predictions significantly differ from the input transcribed speech. This shows the importance of the visual modality and of the fine-tuning stage that enable Vid2Seq to adapt its predictions to the target dense video captioning task. Lastly, note how Vid2Seq is able to densely caption various videos. For instance, a video of human activities in this slide, or an instructional cooking video in the previous slide. Additional examples are included in a separate video, of which the link is below. In summary, we introduce Vid2Seq, a visual language model for dense video captioning. We show that Vid2Seq largely benefits from pre-training on unlabeled narrative video at scale. The pre-trained Vid2Seq model improves the state-of-the-art on various benchmarks of dense video captioning, video paragraph captioning, and video clip captioning, and also generalizes well to future settings. More details and insight are included in our paper.